Hello students, today we will be discussing the quick solutions of All India Akash Test Series JEE Advanced Test 7A Paper 2 Mathematics, which was held on 5th May 2019. So let us start with the question number 37, in which we have to find the value of the expression tan pi by 9 plus 2 times tan 2 pi by 9 plus 4 times tan 4 pi by 9 plus 8 into cot 8 pi by 9. Here we will make use of the formula, that is 2 times cot 2 theta is equal to cot theta minus tan theta. Let us use this property here to solve this question. Now, the expression can be written as tan pi by 9 plus 2 times tan 2 pi by 9 plus 4 times tan 4 pi by 9 plus 8 cot 8 pi by 9 can be written as 4 times cot 4 pi by 9 minus 4 times tan 4 pi by 9. So here it can be observed that these two terms will get directly cancelled. So we are left with tan pi by 9 plus 2 times tan 2 pi by 9 plus 4 times cot 4 pi by 9, which again can be written as 2 times cot 2 pi by 9 minus 2 times tan of 2 pi by 9. Similarly, here also these two terms will get cancelled. So this is equal to tan pi by 9. For one more case, let's again use this property. So this will be equal to cot of pi by 9 minus tan of pi by 9. So cancelling these two again, we can check that the value of the given expression is equal to cot pi by 9. So let us solve all the four options to check which is equal to cot pi by 9. Option number A, we are given cot theta minus tan theta, that is equal to 2 times cot 2 theta, that is 2 times cot pi by 9. 1 by 2 will get cancelled, so it is equal to cot pi by 9. So option number A is correct. Now option number B, we are given 1 upon sine of 2 pi by 9 plus cos 2 pi by 9 divided by sine 2 pi by 9. So this is equal to 1 plus cos 2 theta, that is equal to 2 times cos square pi by 9, and in the denominator sine 2 theta can be written as 2 times sine pi by 9 into cos pi by 9. So cancelling 2 times cos pi by 9, we will get cot pi by 9, which means that option number B is also correct. Now option number C, which says that 1 plus cos 2 pi by 9, that can be written as 2 times cos square pi by 9 plus cos pi by 9, and in the denominator we have sine 2 pi by 9, that can be written as 2 times sine pi by 9 into cos pi by 9 plus sine pi by 9 is already given. So this is equal to, taking cos pi by 9 common, we will get 1 plus 2 times cos pi by 9. In the denominator also, if we take sine pi by 9 common, we will get 1 plus 2 times cos pi by 9, which both will get cancelled. So this is again equal to cot pi by 9, which means that option number C is also correct. Now let's check the last option, that is option number D, which says that sine 2 pi by 9, let's write it as 2 times sine pi by 9 into cos pi by 9. Taking cos pi by 9 common, we are left with 2 times sine pi by 9 plus 1, and in the denominator 1 minus cos 2 pi by 9, that can be written as 2 times sine square pi by 9 plus sine pi by 9. Here also in the denominator, if we take sine pi by 9 common, so 1 plus 2 times sine pi by 9 will get cancelled, and we will be left with cot pi by 9. So option number D is also correct, which means that answer of this question will be A, B, C and D option. Question number 38, which says that let fx is equal to x cube plus ax square plus bx plus c for all x belonging to R, where a, b, c are the sides of a triangle ABC, such that a plus b minus c is equal to 2 and 2ab minus c square is equal to 4. Then we have to answer the following options. Now, it has been given that a plus b minus 2 is equal to c and 2ab minus 4 is given to be equal to c square. So let us put the value of c here. We will get a plus b minus 2 whole square, which means that 2ab minus 4 is equal to, opening the square, we will get a square plus b square plus 4 plus 2ab minus 4b minus 4a. Now, cancelling 2ab on both sides, we will get a square plus b square minus 4a minus 4b plus 8 equal to 0. That can be written as a minus 2 whole square plus b minus 2 whole square equal to 0. Sum of two perfect squares equal to 0, which means that both of them should be 0 separately. That is, a should be equal to 2 and b should also be equal to 2. So, putting the value back, we can find the value of c equal to a plus b minus 2, that is again 2. That is, the triangle ABC is an equilateral triangle whose area will be equal to root 3 by 4 into 2 whole square, that is root 3. That is, option number D is correct. Option number A is incorrect. Now, fx will be equal to x cube plus 2x square plus 2x plus 2. This is the function fx. Now we have to find its minimum value. For cubic function, as it is going from minus infinity to infinity, so its minimum value will be minus infinity. So option number B is incorrect, and we have to find its monotonicity. So let us find f dash x, that is equal to 3x square plus 4x plus 2. Now its discriminant will be equal to 14 minus 24, that is less than 0, which means that fx is always increasing function. That is, it is monotonic function. So we can say that option number C is also correct. That is, answer of this question will be C and D. Next is question number 39. Here two sets are given, that is A and B. We have to find the number of functions from A to B such that the following conditions are given. A very interesting and good question. So let us solve it. We are given two sets, that is A and B, 0, 1, 2, and here we have minus 2, minus 1, 0, 1, 2, 3, 4. Now, option number A says that for all I greater than j, f of I should be less than equal to f of j. Now we have three cases here. That is, the elements of A have distinct images in set B. That is, case 1, when we have distinct images, all three images are distinct. Now, from these 7 images, let us select any 3. In 7C3 ways, I have selected any 3 from set B. Now, as all 3 are distinct, so there is only one way in which we can make the ordered pair. So there is only one way in which we can link them. So into 1. Now similarly, case 2, in which 2 images are same and 1 is distinct. Now this means that from the 7 elements we will select only 2 and we will have 2 ways in which 2 can be same. So it will be 7C2 into 2. Now case 3, when all 3 images are alike, that is, all 3 are alike, that is, we will select only 1 from the 7 in 7C1 ways, and in only one way it can be assigned. So the number of ways will be 7. So total number of ways will be 7C3 that is 35, plus 7c2 into 2, that is 42, plus 7. So our answer will be 84. That is option number A is correct. Now, in the similar fashion, let us firstly solve option number D, which says that for all I greater than j, f of I will be greater than equal to f of j. Now in this also we will have exactly same number of functions. So for this condition also we will have 84 functions. So this option is incorrect. Now option number C says that f of I should be greater than f of j for all I greater than j, which means that all are distinct, which means that only case 1 is present here. That is 35 number of functions will be there. So option number C is also correct. Now option number B, we have to check 1 functions. For 1 functions, it will be equal to 7 into 6 into 5. That is 30 into 7, that is 210. So option number B is also correct. So answer of this question will be A, B and C option. Next is question number 40, which says that if Sn denotes the sum of first n terms of the series 9 into 5 raised to the power minus 2 upon 1 into 2 and so on, and Tr denotes the rth term of this series, then we have to find the sum of this series. Now rth term can be assumed equal to 4r plus 5 divided by r into r plus 1 into 5 raised to the power r plus 1. So this can be written equal to 5r plus 5 minus r divided by r into r plus 1 into 5 raised to the power r plus 1. So this is equal to 5 times r plus 1 can be cancelled, r into 5 raised to the power r plus 1 minus 1 upon cancelling r plus 1 into 5 raised to the power r plus 1. So this is the rth term. So sum of n terms will be equal to 5 upon 1 into 5 raised to the power 2 minus 1 upon n plus 1 into 5 raised to the power n plus 1. Right? So we can say that limit n tending to infinity Sn will be equal to 1 by 5. So from the given options, option number B is correct and option number D is incorrect. Now we have to find the limit of Tn upon Tn plus 1. So Tn upon Tn plus 1, that will be equal to 4n plus 5 divided by n multiplied with n plus 1 into 5 raised to the power n plus 1 multiplied with 4 into n plus 1, that is 4n plus 9, and in the numerator we will get n plus 1 into n plus 2 into 5 raised to the power n plus 2. So limit of n tending to infinity Tn upon Tn plus 1 will be equal to 5. So option number C is correct, which means that answer of this question is B and C option. Next is question number 41, which says that if domain of the function fx is 0 to 10, then the domain of f of greatest integer of x minus x square plus 10 is a subset of. Right. So we can say that GIF of x minus x square plus 10 is going from 0 to 10, which means that GIF of x minus x square is going from minus 10 to 0. Now, further, greatest integer of x will go from x square minus 10 up till x square. Now, to solve this, let us draw the curve of y equal to x square and y equal to x square minus 10, and we will plot the graph of floor of x. Now floor of x will go like this: 0 to 1, 1 to 2, 2 to 3, 3 to 4. Right? This is 3 and this is 4. And this is 1 comma 1. And In the negative side also, it will be like this, from -1 to 0, from -3 to -2. So this is -3 and this is -2. Now, it can be seen that it will cut x square minus 10 at x equal to √13, because the value of floor x is 3, and here it will cut at x equal to -√7. So floor of x will be between these two curves for x going from -√7 up till √13. So it is a subset of -3 to 5 and -2√2 up till √13. It is not a subset of these two. So answer of this question is B and D option. Next is question number 42, which says that if fx is equal to √x minus 2 minus 2 divided by under root of x cube minus 14x square plus 60x minus 72 for all x greater than 2, then the value of integral from 2 to 11 fx dx is equal to. Now here in the denominator a cubic function is given. By hit and trial it can be found that its factors can be written as x minus 2 into x minus 6 whole square. So fx can be written equal to under root of x minus 2 minus 2 divided by x minus 2 under root into modulus of x minus 6. Now for x less than 6 it will be written as 6 minus x. So we will get fx equal to, after rationalizing, -1 upon under root of x minus 2 into under root x minus 2 plus 2 when x is less than 6, and it will be equal to 1 divided by under root of x minus 2 multiplied with under root x minus 2 plus 2 when x is greater than 6. Now we have to find integral. So integral will be equal to 2 to 6 minus 1 divided by root x minus 2 into root x minus 2 plus 2 into dx, plus from 6 to 11 it will be 1 divided by root x minus 2 multiplied with root x minus 2 plus 2 dx. Now to solve this integrals, let us put root x minus 2 plus 2 equal to t. So its differentiation will give me 1 by 2 under root x minus 2 dx equal to dt. So this can be written equal to minus 2 times dt upon t. Now when x is 2, the value of t will be 2. When x is 6, the value will be 4. Similarly here we will get integral 2 upon t dt from 4. When x is 11, then the value is 5. So this is equal to minus 2 into ln of t from 2 to 4 plus 2 times ln of t from 4 to 5. So this value can be written equal to minus 2 times ln 4 minus ln 2, that is ln 2, plus 2 times ln 5 minus ln 4, that is 2 times ln 5 minus 2 times ln 4. So this is equal to 2 times ln 5 minus 3 times ln 4, that is equal to ln 25 minus ln 64. So this is equal to ln of 25 upon 64. So from the given options, it can be seen that only option number D is the correct answer.